fission?
When the atom splits.
Something splits, okay? What little particle hits uranium to get that started? Neutron. Close enough, okay? Neutron. And then whenever fission happens, we get 2 new elements. We get lots of energy and 3 neutrons, okay? What are those neutrons going to go do? They're going to go start more fission processes, okay? Starting a what reaction? A chain reaction, good, okay? Today, we're going to talk about fusion. Hey, I need side conversations to stop, please. I am not mentally strong enough to teach while everybody else is talking. What?
Are we already done with the warm-up?
Should be, yeah.
Should be done.
Okay, so fusion is the opposite of fission. Okay, fission splits things. Fusion is going to combine things. Okay, if you think of the word fuse, like if you fuse together some wires or something like that, you're going to bring them together. So fusion is going to combine atoms. All right, 2 small ones combine to form a larger atom. So our driving question today, what we want to find out is what is nuclear fusion and how does it happen? What is nuclear fusion and how does it happen? All right, the F-U-S in fusion, F-U-S, stems from Latin and it means to melt. Fusion means to melt. Or fuse means to melt. Hey, I need you to quit talking, please.
Oh, it doesn't show you.
Waiting on y'all. Please hush. Understand? Please hush. Okay, so our definition of fusion is going to be with high temperatures and pressure, lighter nuclei combine to form a larger nucleus. Okay, combine is our key word for fusion. All right, we're going to combine 2 atoms into a bigger atom. Alright, these high temperatures are super, super high. Okay? They need over 10 million degrees of Celsius to fuse. Okay, that is really, really hot. Alright? Needs temperatures of over 10 million degrees Celsius in order for things to start fusing together. Alright, let's talk about the fusion process. What exactly happens? Alright? We have 2 small atoms here. Okay, this is just their nucleus. So 1 proton, 1 neutron. All right, we have 2 of those. Those are called deuterium. All right, I know that's a weird word. It's a version of hydrogen. So deuterium. It's just a different version of hydrogen. Okay, the science word is an isotope, but that just means version. Okay, the version of hydrogen with 1 neutron is called deuterium or heavy hydrogen, and we use H2 to symbolize that.
Why don't we just call it hydrogen?
Because there's different versions of hydrogen, and this is a very specific version. Alright, so I have two
Hydrogen.
deuterium atoms here. Alright? I'm going to put them under a lot of pressure, and I'm going to crank up the temperature, and they're going to fuse together to form a bigger atom. Okay? So these two are now formed together as one helium atom. So we went from versions of hydrogen to now a version of helium. Okay? A helium-4 nucleus, which is just going to be 2 protons plus 2 neutrons. So those two little deuterium atoms fused together, and now I have a helium-4 nucleus. Okay? And lots of energy. So whenever those hydrogen atoms slam together, a whole bunch of energy is going to occur, and it's going to form that helium atom. Okay? So this right here, those are our products of fusion. Products of fusion, a lot of energy and a helium-4 nucleus. All right, what was a negative side effect of fission?
Radiation.
Radioactive waste. Okay, fusion is really cool because it does not produce radioactive waste.
The whole.
Does not produce radioactive waste. Okay, so if fusion makes a bunch of energy, doesn't make radioactive waste, why don't we use that instead of fission in our nuclear power plants?
Because we're poor.
Why are we not using fusion instead of fission?
Because you can't. You can't
We can't get that high of temperature and that high of pressure here on Earth. Okay? What is something that has really high temperatures already? The sun. So fusion naturally occurs in the sun and stars. Okay? Fusion takes place in the sun and stars because the sun is so hot.
I got it.
Okay, I need you guys, I'm going to give you a minute or so. Answer these questions down here. Tell me if that statement is fusion or if that statement is fission. Okay, these questions down here. I'll give you about a minute and 30 seconds and we'll go over them together.
Can they not be both?
No.
A minute and 30 seconds.
You know what? That just makes me so mad. You.
Yes.
What's that for?
Pressure.
What's the difference? They're all dirty.
You got about 30 seconds to answer those on your own.
I know it's
Alright, which process needs very high temperatures? Fusion. What is utilized in an atomic bomb? Fission. Involves a neutron bombarding a giant unstable atom. Fission. Does not produce radioactive waste. Fusion. Involves energy being produced when two atoms combine. Fusion. Okay, two atoms coming together, combine is the key word there. Can be critical or supercritical. Fission. Involves two heavy hydrogen atoms smashing together. Fusion. Involves energy being released when a giant atom splits.
Fission.
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 Used to make energy in nuclear power plant.
Fusion.
Fission.
Yeah.
Produces radioactive waste.
Fission.
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 Alright, let's kind of
Fission.
remember a couple things we talked about yesterday.
Fusion.
In your own words, describe the fission reaction that occurs in natural power plants versus that in an atomic bomb. So I have a power plant
So easy. One.
and I have an atomic bomb. What's the difference?
Power plants are more controlled.
Is it
Quick
critical
light
process?
instead.
Yes, Calissa. Okay, power plants use the critical chain reaction, which is slower, so it's easier to control. Atomic bomb uses what? Supercritical, yes. Alright, that paper you picked up today is what we're going to work on next. This one I need you to flip to the back.
No.
Wait, so we do
You
this.
know
They're up here.
What we do with this?
You keep
Sorry,
it.
Linda, but that's not. They got traffic all over.
What did you do?
Alright, on the back of this one, we're going to fill out this table together. On the back of this one, we're going to fill out this table right here. Okay, you picked this up today whenever you walked in.
I didn't pick it up. It's not in
Linda,
here.
you win those eyebrows or Linda? I want to read that one.
What are we gonna do? Zip them up? Wow.
Yeah, you're going to need them for today's assignment. Okay, listen please. Over here on the left is just going to be fission, this gray column. We're going to go through that one first. So we're going to start at the top and work our way down through fission, and then we'll do fusion second. Okay? So the first box, what's the definition? Somebody give me a simple definition of fission.
Of a large atom?
Oh, but unstable.
Bingo.
To split.
Splitting a large unstable atom. Linda, why aren't you writing? Okay, definition of fission. Splitting a large unstable atom. Natural occurrence, so fission can't happen on its own. Us humans have to make it happen. So we're going to put does not occur naturally or happen naturally.
I can't see my answer that I wrote my homework after.
We don't know that yet. You never know. A tree could fall, hit an atom in the right spot, and it could break.
But it has to be a uranium atom.
Well, maybe uranium.
There's not just uranium floating around underneath trees.
You never know. I beg to differ.
Alright, byproducts. What's the bad thing that fission produces?
Radioactive.
Uranium. Why would you- Let me see it.
That is a great hypothesis.
Makes sense.
Byproducts, radioactive waste.
Writing that stuff down.
Energy requirement. So, all that's required of fission is that neutron hits a uranium atom, okay? So it actually takes very little energy to get started.
To split two atoms.
Shut up, Linda. Come on.
Energy requirement takes little energy to get started. So energy released. All I've said so far is that it releases a lot of energy, okay? Today I'm going to be a little bit more specific. So this is a nuclear reaction, okay? The other types of reactions are chemical, right? So that's like mixing chemicals in a lab. That's a chemical reaction. Fission is going to produce or release 1 million more times
Greater.
greater than chemical reactions. But less energy than fusion. Okay, so fusion, it produces the most out of anything.
My name is made up my heart is so sick. Now, gotta be
Shut up.
when the talking distracting integrated physics and chemistry.
What's a nuclear weapon?
Atomic bomb.
Atomic bomb.
Yeah. Big blue boy.
Japan started it.
Japan. It's not the only Olympics. Okay, I love it.
That's why we-
Y'all are so racist.
Energy produced. So we use this energy produced in nuclear power plants.
So we want to do racism. Homophobia. Don't vote
Can't place.
And what big atom is used in fission? Uranium. So that's the fuel that drives fission. Is uranium.
You know they do, right? I know.
Our people just homophobic. It's just a house. There's no inside.
Okay, so I am going to add information about nuclear power plants over here. I need you to add it at the bottom where I did on my notes. Okay, so we're going to list 2 positives and 2 negatives of nuclear power plants. I put mine at the bottom here. Okay, that's where you're going to write this information. I have an arrow pointing to that energy produced section. Okay, an arrow pointing to energy produced. So, nuclear power plants. Positives. You're writing this at the very bottom of your paper.
Creates energy.
What? Say that again.
I said creates energy.
Yes, lots of energy in little time. Lots of energy in little time. That's a positive of a nuclear power plant.
The greenhouse gases. Fewer greenhouse gases than fossil fuels.
Yes. Less pollution. Okay.
I thought
Good
the
job.
F in there was like something different.
Less pollution than fossil fuels. So that's the second positive of using a nuclear power plant. There's less pollution than fossil fuels. What's a bad thing about fission?
Radioactive blows up. Edward. It's very dangerous.
How are you?
Okay, so the 2 negatives of nuclear power plants is that it is very dangerous, like Chernobyl, it went boom, and it produces radiation. Can you wait till I'm done teaching?
How long are these? How really gonna go?
We just gotta go through fusion and I'm done. It's gonna go fast, I promise.
I'm serious.
If you can wait, I would really appreciate it.
Like how long?
Just let me get started. Ready? Set, go. Somebody give me a definition of fusion.
Hey.
Stop talking about it. That's
The
disgusting.
combining of atoms. Write down it. Come on. Quit talking to my boyfriend.
Combining small atoms into a larger one. Naturally occurs in the
Sun.
and stars.
Why can't we heat up to 1,000,000 Celsius on Earth?
We just don't have enough power to do that. And it's also not enough atmospheric pressure.
Why
Can we
not?
like go condense it?
Now why don't we just get one of those vacuums or something?
It costs money.
Okay, we have money.
Byproducts, there are none.
None.
It doesn't make radioactive waste.
I gotta pee, man.
Energy requirement. So what are the two things required for fusion to happen? High,
Energy.
high,
High temperature. Heat and pressure.
yep, high temperature and pressure.
Ow.
High temp and pressure required.
This little piggy.
Fusion releases 3 to 4 more times greater energy than fission. Raphael, you're gonna come sit by me? Alright, nuclear weapons, please quit talking. You can talk when I'm done. This has only been tested, okay? In Russia they have tested it, but a bomb that could be made from fusion is called a hydrogen bomb because of those hydrogen atoms fusing together, and it would be way more powerful than an atomic bomb.
Why do we need to make that? That would be
To kill people that attack America.
What if we just like shoot it up and it breaks and kills us?
Energy produced, so we don't have like a nuclear power plant yet. Okay, it's all just being experimented. So we're just gonna write experimental.
Experimental nukes.
Okay, it's all being experimented at the moment. Fuel, those two small atoms that get fusion started are called deuterium.
I'm sorry.
Which is just a version of hydrogen.
See,
Wait, so they made a hydrogen bomb?
In
I thought we
Russia,
couldn't do it.
what?
I thought we couldn't make.
It's just being tested. I don't know how successful it was or anything like that.
Why are they testing that?
They're probably going to kill America.
Ow.
Okay, I need you to keep these things and do 4.2 on Canvas. 4.2 assignment on Canvas. Hey, give me a pass, Dylan.